Hello, today we're going to be discussing transformations of absolute value functions. So the rhythm of these notes are going to be a little bit different than what we've done in the past. We're going to be doing more of an exploratory thing, and it should connect directly to what we have done in the past with transformations of functions. So the first thing you're going to want to do is you're going to want to go to this website, and I've included the link up here so that you could just click on it. When you do that, you should see this. So you have this absolute value function. We know it's absolute value because the shape of the graph is a V. You can see your equation here is the absolute value of x. Now, step 1 on the notes says that graphs 1 and 2 are already highlighted. We will want to adjust the K slider on graph 2 to see what K does to your graph. So what you're going to do is in a moment you'll pause the video and you'll try each of these. And the way you try them is this K value here. You can slide this so you can see what it does to the graph, or you can type in the specific numbers that it says. And the black graph is the original graph, and then the K is the red graph. So the red graph is how, like when you type in a number for K, what happens to your graph. So what you're going to do right now is you're going to go ahead and type in +2, +3, -1, and then -4. And you're going to write next to each of these, like what happened to your graph? How did it move for each of these? Then when you're done, you're going to summarize what K does to the graph. Okay, so go ahead and do that. Take a moment and try each of those and see what happens. So pause the video and go ahead and try those. So we should have seen what K does to our graph. So now what we're going to do is we're going to move on to number 2. So we want to leave graph number 1 on, but we want to turn off K, which was graph 2, and turn on graph 4. Okay, so I'm going to help you with what this looks like. So going back to our website here, to turn off this graph, what you're going to do is you're going to click on the button here. And then to turn on this next one, you're going to click over here, and you should have this green function. So now we're going to be dealing with 8. So looking at these ones, we're going to have x plus 2 and x plus 3 and x minus 1 and x minus 4. So looking at these ones, we're going to end up with moving our graph around like this, and we're going to see what happens when we mess with h on our graph. Okay, so go ahead and take these and type those in and see what happens to your graph. Next to these, you want to write down what is actually happening to your graph and then summarize it down below. Okay, so pause the video, go ahead and try that, and then come back. And now we're going to do the same idea with the number out in front, your A value. So we're going to turn off graph 4 and turn on graph 6, like we did for the last one. And right now A is 0, but you could type in different values here. So you could type in the 2 to see what happens to your graph. So the black graph is the original graph, and the purple is the new graph with messing with A. So what I want you to do is go ahead and graph each of these. Notice what happens to your graph with these different values. Go ahead and describe what's happening with your graph for each of these. And then in general, how does that A value change your graph? What's happening there? So pause the video and go ahead and try that. So now what we're going to do is we're going to go ahead and look at these functions as a whole. So what we can do is we can type these equations in into our graphs here, and we want to see what's going to happen here. But before we do that, if there's a -3 and a +2 here, what I want you to do first is guess, what is this graph going to look like? How is it being moved? Then you're going to type this into Desmos and see what actually happens. So for instance, for this one, we're going to turn off all of the graphs except for the very last one. And then we're going to type in whatever was there. So for this one, it was x minus 3 plus 2, and we're going to see, did our description match our graph? Then you're going to go do the next one, and then you're going to type everything in at the end and see did your guess match your graph. So go ahead and take a moment and guess for these four what would happen, and then type it in and see if it actually worked out. So now that we have gotten the idea of things, how everything's being moved and everything, we want to write the equation of this absolute value function. So take a moment and looking at this graph here, what I'd like you to do is just kind of think about how did this graph get moved and what would it look like if you actually typed this in to an equation here. So I want you to go ahead and guess what you think would be where. So pause the video and guess, and then come back once you've made your guess. So we have moved right 1 and down 3. So to move right 1, it's an x minus 1. Inside, make sure you're using absolute values. And then down 3 would be minus 3 at the end. And our stretch of this graph, or our slope, is up 1 over 2. So our slope here, or our stretch, should be 1/2. So that's number 5, what we should end up with. 1/2 absolute value of x minus 1 minus 3. So this summary part here we will do together. So we want to describe what A, H, and K does to our graph. So A was our vertical stretch or compression. Just like our linear functions, it was a stretch if you had a number there greater than 1. So for instance, if it was a 2 or a 3, it stretched it vertically. If your number was a fraction, that's what this is saying. If A is a fraction between 0 and 1, so like 1/2, 3/4, something like that, that was your compression. It also reflects the graph or flips the graph over your x-axis. And it does that if A is negative. So if there's a negative sign out in front, it flips it over. For H, anything inside the H moves it left or right. Okay? So it would move left if you had x plus a number inside the absolute values. And it would move right if you had x minus a number inside the absolute values. This matches up with everything that we did with linear functions as well. So if you think back to like how those moved around, this moves around the exact same way. Which means K is going to be our up or down. It's going to move our graph up or down. So this is always the number outside of the absolute values. If you have x plus a number, but the plus that number is outside the absolute values, it moves up. Whereas if it's minus some number outside the absolute values, it does end up moving your graph down. So these all match up with things that you have seen before, but the only difference is that because you have these absolute value bars, the shape of the graph is going to start off as a V, and we're going to move that V shape all around. So we will work more on this tomorrow as to like how do we actually graph accurate points now that we know how it's all moved around. So thank you very much for listening. I hope this helped.